We move on now to Chapter 20, Shaping the Earth's Surface. And the surface of the Earth is involved in an ongoing process of destruction and tearing down of higher elevations. This right here does occur, and this is erosion is a very common example of this. And the slow changes result in the breakup, crumbling, or other destruction of solid rock. And this includes physical, chemical, and biological processes. You've all seen the rocks that we have alongside the roads in Missouri. You see trees growing out from them. That's a biological process that is essentially causing the rocks to come apart. Now, weathering is a slow changes resulting in the break, crumbling, and other destruction of solid rock. If you have a fissure in a rock, as that freezes and thaws, what can happen is it will be forcing that apart until finally it's just going to be broken off completely. Mechanical weathering is a physical breakup without chemical changes. A disintegration process, as we saw before there, by frost, by trees growing in them, as I mentioned earlier. Exfoliation, reduced pressure effects, fractures caused by the expansion of underlying rock. And you can see some different things taking place here. Chemical weathering is decomposition of minerals by chemical reactions. We have oxidation that can take place because we have a good part of 20% about of our atmosphere is oxygen. And so any of the iron will oxidize. Other materials can oxidize as well. Carbon dioxide will dissolve in water, forming carbonic acid, and that will cause reactions as well. And this easily dissolves limestone. Hydration is reactions with water, and so things can dissolve in water or combine with water, and so form all sorts of different interesting geological structures. Soils are mixtures of unconsolidated weathered earth materials and humus. Humus is the decaying plant material, right? That's humus. And the other is, so you have minerals and organic material making up soil. Weathered materials include quartz, sand, clay, metal oxides, and salts. The soil is usually called by other names. Loam, for example, consists of varying amounts of sand, silt, and clay mixed with an abundance of humus, and this is also known as topsoil. This is what you pay about $3 a bag for at your local stores. Especially here in Missouri, where we have very, very thin soil layers. Less fertile soil beneath the topsoil is subsoil. Yeah, I mean, we have maybe 1 inch, 2 inches in most places, unless you're down in a valley next to a river someplace. And the subsoil contains more rock mineral accumulation and contains less of the humus. There are places in Iowa and further north that have many, many feet of topsoil. The erosion is the mass movement. It's caused by gravity, and its creep usually has a very slow effect, and then eventually the landslide is a very rapid one where something breaks off and can whether it's snow or something else, will cause very dramatic changes downhill. Running water is the most important of all gravitational erosion processes. 3-stream transport mechanisms. When that water is going over the waterfall or down through a river, it's got dissolved material in it. Okay, and that dissolved material comes, a lot of it, from the rocks and from the organic material. Suspended materials, and those suspended materials can be logs and other fairly large things when we have some of our very heavy thunderstorms here in Missouri. Rolling, bouncing, sliding along the stream bed are different things as well. Just in other words, you've got dissolved materials, suspended materials, and this right here is just the surface action that changes that stream bed over time. So, stream development, landmass is recently uplifted, steep gradients, V-shaped valleys, boulders, rapids, waterfalls, all those sorts of things are happening all the time. The stream gradient is smooth and lower, that meanders over a floodplain. This goes along, for example, along the Mississippi, right? This right here is some of the creeks and streams that we have here in the Ozarks. We actually had a lot of mills down in this section of the state of Missouri a number of years ago, by this very rapid waterfall movement down certain waterfalls that was then used to grind meal and other different materials. Old age, very low gradient, broad, gently sloping valleys, sluggish flow, more floods, and that type of thing. This is down here, delta areas. Now, the delta actually is a deposit of sediment at the mouth or river of a stream or a river. And the stream flows and dissipates into an ocean or into a lake, and its erosive or sediment carrying abilities are lost then at that particular time once it gets to the lake. Massive ice on land that moves under its own weight is a glacier. And glaciers are either forming, or they're receding, or they're staying the same. There's the form from snow accumulated over a number of years. Alpine glaciers, these are the ones in the Alps around Switzerland. They form at high elevations, flow through valleys, and are also valley glaciers. So when you go to St. Moritz and Gstaad and those places to ski, what you're actually doing is you're skiing down the side of a glacier. And it's even in the summer months, it's pretty tough sledding on going down there. You have to have very sharp edges to your skis to ski in St. Moritz and Gstaad. Continental glaciers, these cover large areas of a continent. This is in Greenland and Antarctica today, and of course in the northern part of Siberia. Glacier erosion are three mechanisms. Bulldozing. This forms deposits called moraines, not morass. And essentially this is just that old glacier moving on down, just pushing everything in front of it, right? Just like a bulldozer. Abrasion, this produces powdery, silt-sized rock flour. And plucking. This is the glacier water freezes in the surrounding rocks and then pulls it along as it goes further in one direction or the other. The wind is considerably less efficient than water or ice, but nevertheless, if you've ever traveled through New Mexico or Arizona, your car is going to have some natural sandblasting at times from some of the strong winds that you get there. At least I've experienced that. I guess it probably should occur further north and along Nevada and that, but places where I've seen it primarily have been in New Mexico and in Arizona. And the shape depends upon prevailing winds in terms of how it smooths those things off. And if you look at some of the shapes of stones in Monument Valley and that, a lot of that is because of this wind type of erosion. And the sand just essentially sandblasts those particular rocks. There's also wind-blown deposits. Dunes can form. There's a very large dune along the shores of Michigan, on the shores of between Lake Michigan and on Michigan. It's called the Sleeping Bear Sand Dunes, and it stretches over a couple of miles in width, and then along the shore is for many, many miles long. And loess is fine dust deposited over a large area. So the dunes are what you usually associate with a desert, but it can happen right next to a very large lake as well. Developments of landscapes. Landforms are the Earth's surfaces. The broad features are mountains, plains, plateaus. Minor features are hills, valleys, canyons. Whether it's a mountain or a hill depends upon where you are. A mountain here in the Ozarks would be a hill in West Virginia. or in the Rockies. Generalizations based upon rock structure, weathering and erosion, stages of erosion for those different ones. Rock structure determines the shape of the minor landforms. And again, we talked about the different types of rocks, the attitude of the rock, the effect of disturbance by faulting or folding. Faulting or folding can hasten erosion and that type of thing. So whether the not only the type, but also the configuration of the rock determines that rock structure. Weathering and erosion processes are influenced and controlled by factors such as climate and elevation. If it's warm and moist, you've got a lot of chemical weathering. Landforms have softer, rounded features. If it's a dry climate, mechanical weathering dominates. Sharp, angular outlines are more common. Stages of development, and it's just how things change with time, with the effects of those different things. And that's the end of that chapter. I hope you enjoyed today's lecture, and you can move on now to the homework problems as well as the lab.